to parent. I have a capitalization issue. Oops. There you go. Get parent. And I'm going to plug that here. So I want those to have the IK control as a parent. Nicely enough, Ferris made a variable that is called get IK leg control. Cool, compiling. And let's do that for the other side, get IK right. There you go, right leg IK control. And now, if I grab those in the hierarchy, you could see that those controls are children of the IK. So if I move my IK control, I have all those reverse foot control coming with it. They're not doing anything yet. We haven't done any logic to the forward graph. But we can take them to the forward graph now. One more thing I want to do. I will want to have access to those controls that I just created. And Ferris already showed you that it's quite convenient to store them as metadata of the bone. So I'm going to do that again. I'm going to grab from the bone. I'm going to do set metadata. And I'm going to pass this control as a value. Those noodles crossing, I don't like that, so I'm going to do a little quick redirector. Oops. Didn't mean to do that. I'm going to delete this one and move that up. Cool. I could spend a lot more time cleaning the graph. Matt certainly would spend much more time, but I think that's going to be good enough. So cool. We're going to name that control, and we are good to go. Excellent. So now we move to the forward graph, and we, like I said, so we have our left leg here and our right leg there. So I will want some of the logic to happen before and then some of it happen half after. So the first thing I'm going to do just for convenience, I'm going to create a sequence node here. And I'm going to plug that right there and right there. Cool. So I don't have to deal with those very long wires. All right. So I have my left bones. And what I would like to do, if I remember correctly, I just want to drive the IK with the last control, because the last control is a child of the other control, so they're all going to come with it. And if you remember from Ferris' lessons, he was kind enough to put this IK null underneath, and that was for the reverse foot. So the idea is that I'm not going to touch the IK control because that's what animators want to touch, but I want to be able to offset the effector of the leg. So let's grab this effector. So I'm going to get the IK control first. Get leg IK control. And if you look inside the construction of the limb, Ferris was kind enough to spawn that null, and then he added it as the metadata of the IK control. So it's very convenient. I can get the control, and then from here I can do a get metadata, and I can get the effector. It's the type is a rig element key. So that's my null. Excellent. And what I want to do is, like I said, I want to, if you want to say parent constraints, or again, I'm going to say project, I want to project that null to this ball control, because I want to be able to rotate that control and that null to follow along. So this control here is the control of the first bone of the hierarchy, the ball joint. So I'm going to grab the first bone of the hierarchy. I'm going to grab the metadata, because that's where I have stored my control. So one of my metadata is called control. Oh, did we show you that whenever you have metadata on an item, if I select this item here, you can see the metadata inside the detail panel. So here you can see that this bone has a metadata called control, and that the value is the control that I have created. Cool. So this is a rig element key. And like I said, we want to project this effector. So I'm going to do a project to new parent from this effector to the last control, or the ball joint control. And then I'm going to do press 2 to do a set transform and plug that all together. All right, cool. I can insert that over here. And in theory, that's going to offset our IK. Amazing. And because it's a child of the IK control, if I move that around, you can see that this is moving. I can rotate it from the heel. Everything is working. What is not working yet is if I rotate from here, you can see that the toes are not aligned to the world. And this is what usually we want for a reverse foot. We want to be able to keep the toes aligned to the world. So let's do that. First, we're just gonna convert all that to a function, because obviously I want to keep things clean. Collapse to function, created my input nicely. I'm going to call that the pre-forward foot. Again, I'm going to do some logic after the leg, and we'll show at the end exactly why I'm doing all that. So I'm renaming this pre-forward because I'm going to have a post-forward or a forward foot as well. And for the function, I'm just going to rename the inputs. This is my IK control. And those are my bones. Excellent. Cool. So now we can go after the leg has been solved. So here we are offsetting this this effector of the leg. Then here in the forward limb, we are solving the IK of the limb. So that's why I want my effector to be in position before I solve the IK. And then after it's done, I want to readjust the orientation of the toes. So I'm going to grab my left bones, my left foot bones. And the first thing I'm going to do is for each of them, I'm going to grab the control and I'm just going to snap the bones on the control. So for each, get metadata, I want to get the control. I know it's a rig element key. And I want to get the transform. And I want to set the bone to be, not get transform, but set transform. I want to set the bone to be the transform of the control. There was no initial offset when I created my control. If you remember, inside my construction of the foot, I directly I took the position, the transform of the bone, and I applied it to the control. So there's no offset between them. So I don't need to do a project or anything. I can simply use the actual value of the transform directly inside my bone. So if I do that over here and plug that here. Well, it hasn't really changed anything. The only thing you should be able, the only difference you can tell is that when I rotate the tip, for example, this bone for the heel is staying where it was. If I disconnect, you can see that the bone was moving with the I key, so it was moving here. So that's the only difference for now. So not quite the results I want. My toes are still not aligned with the world. If I rotate this one, it is still no good. I'm just going to turn that into a function. And we're going to rename that to forward foot. Going to dive right into it. And I'm sorry, you're going to have to watch me do a sequence node again and add a couple of pins maybe. I forgot if I need more than, but that's fine. Going to plug my return node at the end and plug that over here. Rename my input bones and get bones and plug that over here. Excellent. So same logic. Nothing has changed. I'm just cleaning the graph, making it into a nice function, and organizing my function so I can read it easily. So what do I want to do? Well, ideally, I want this bone to always point at the next one in the hierarchy. Or I mean, the control is the next one in the hierarchy. Yeah, the control is the thing I want to be able to drive. So I just need to tell that bone always points at the control of the bone after it. So what I can do is from this control, I can get the parent. So for this control, the parent is going to be the tip control. And I want to aim this bone at this one. So here, instead of using directly the transform, I'm going to do an aim math, look at, point at, aim constraints, whatever you want to call it. This is the math you need to have an object pointing in the direction of another one, or to have a transform pointing in direction of a location or anything like that. So we want, from this position, from the position of that control, we want to point at the parent control. We want to, this control is a child of this control, so we want to point at its parent. So from the parent, I can do a get transform as well. And so the target of the primary axis is going to be the position of that control. Cool. Let's plug that to see what's the result. And immediately we can see that we are getting a result that is much more interesting for us. Not quite done yet. If I grab this tip control and rotate it side to side, you see I don't quite have the effect I would like to. The toes are not following the rotation. And this is because we haven't defined a secondary axis. So let's do that right now. From the parent, we can basically use the parent as the space we want to work with, and we're going to use the direction of, if I look at here, the z-axis seems to be this side-to-side direction that I care about. So we're going to say on the z-axis, the target is also going to be the z-axis. And now, if I rotate side to side, I get something better. Cool. Excellent. So that worked. And that's still working with everything else. If I move my IK around, I can now offset the reverse foot and move things side to side. Amazing. We're going to copy that over to the other side quickly. So I'm going to do the pre-forward solve for the right foot, getting the right foot bones. And here I'm going to get the IK leg. Yeah, that should be this one. I'm going to plug that here and there. And same thing on the after the sole of the leg, of the right leg. I'm going to get my bones again for the right foot. And hoping that everything's going to be okay. It's not. Oops. Look, the toes have disappeared on the left side. Why is that? Well, axes are inverted on the left side, so there's one more thing we need to do. We can jump back in here, and on the aim math, we're saying that x, positive x is the direction we should be pointing, but on the right side, it should be negative x. So what we're going to do is we're going to simply expose this as a pin. I'm going to create a shortcut immediately. I'm going to rename that to primary axis because sometimes we have to deal with a secondary axis. Primary axis, and then I can go back to my forward function, and now I have this new input. And so for the right side, I'm going to say it's not x, it's minus x that we want. And look at that, it's amazing, it's working. Excellent. All right, so important thing now. The reverse foot is done, but I want to talk to you about something regarding that. So why did I do that? Why did I split the reverse foot into a pre-forward and a post-forward? Again, this is not a dependency graph. This is the execution order. And I'm moving an effector that is driving the IK solve. So I want this effector to be in position before before I do the IK solve. So let me just show you what would have happened if I did not respect that rule. If I move everything to the front, well, oops, let's do that. If I grab my control now and move it around, oh, I'm getting some double transformation. Why is that? Well, here we are moving the effector, and then we're moving the toes first, and then we're moving the whole leg. So the toes gets moved twice because they move as part of the RU key and move by the logic I added. So no good. This is not working. I'm getting some double transformation, and on top of that, if I try to rotate it, it's not even working. So what a mess! It's not going to work this way. But what would happen if I take all this logic and put it at the end of the graph? Well, let's do that now, and let's take a look. So now, if I grab my leg and move things around, okay, so that seems to work. And if I grab my heel, yeah, that's still the behavior I expected. What about the ball joint? Hey, everything seems to be working. So what's up here? Why do I need to worry about this post-forward, this pre-forward and post-forward thing that I was doing? Well, it's because you have to keep in mind that the engine is ticking. And back. You have to keep in mind that the engine is ticking all the time. That means that it's not solving just once. It's keep iterating and solving again. So what happened here is after the leg was computed, after the IK solve was computed, we moved the effector. So the leg here is in the wrong position, but we moved the effector, and on the next tick, the effector is in the right position. So the IK solve is computed once again, and it looks like it's in the right place. But it's actually after 2 ticks that you get the right result, not after 1 tick. And it's going to become a problem when you start baking your animation, because when you bake, you run you run 1 tick, and then you bake, and then a second tick, and then you bake. So you're going to see an issue where if you were to bake this to an animation sequence, you would see your leg lagging behind. You will notice that your leg is just not where you expect it to be, even though when you manipulate your rig, everything is looking correct. So let me show you visually how we can see some of that. So after everything here, I'm going to create a branch, and I'm going to use a magic node called once. Once is a node that the first time it's being read is true, and then it's false forever after. So the first tick, this is going to be true. On the second tick, this is going to be false. So what we're going to do is we're going to check where is my ankle after the first tick. So I'm grabbing the bone. I'm going to get the transform. I'm going to put that in a variable because if I draw it directly inside, so I'm going to plug the once here, and everything, and the first tick, it's going to execute the true, and after that, it's always going to execute the false. So I'm going to put that in a variable because if I draw directly in the true, it's going to draw it once and it's going to disappear. So it's going to flicker very quickly, and then you're not going to see anything. So instead, I'm going to draw the result of the transform after 1 tick. I'm going to store that in a variable. So promotes to variable. Let's call that debug. Just it's a temporary variable. We're going to get rid of it. Let's unplug once for now. I want to build my logic first. And then after that, I'm going to get my debug, and I'm going to draw it. Draw transform. When it's not true, or all the time actually. It doesn't matter because false is always going to be executed after the first time. Going to make those a little bit bigger, and hopefully if I compile, you should see the transform. It's right here. Right now it's at origin because this is always false. I haven't plugged the once condition here. So this is never updated. So the debug transform is always at origin for now. So looking good. I'm going to rotate my leg. And now when I tell it to only evaluate once, where is my transform going to be drawn? Well, if you listen carefully, you know that it's not going to be where we expect here at the ankle. And let's do that. I plug it, and indeed, the ankle bone is after one tick still in position, with still aligned with the control, even though it's not what we see in the final result. So now, if I take the my logic and everything pre-forward, I move it in front of the leg, so over here, and I do the same thing. I can disconnect the ones and do it one more time to make sure that it's working. And you can see that now this time it's in the right spot. Again, think about this graph as the execution order of what is going to happen. Your effector is driving the IK solve, so your effector needs to be in the right position before you execute the IK solve. Cool? Well, that was about it for the foot. I want you to keep that in mind, this execution order thing. You will notice that we use that for modules. We have a pre-forward event that is running before the forward event, and then we have a post-forward event as well that is running after the forward solve. This is the events we're using to have the same abilities when we are inside the modules. I don't know if Matt will have the time to cover all of that, but at least, at the very least, in the example, you will see this behavior where we can do certain action when we are in a module. We can tell a module to execute some of its logic before another module or after a module. The order of execution of modules is also very important, obviously, but Matt is going to tell you all about that tomorrow. We're going to take another 5-minute break. I know it's a lot of information. I just want you to be aware of this tick delay issue, because this is something I've seen riggers struggling with. They don't necessarily see it in the viewport in the editor. They're like, everything looks fine. Why is it an issue when I'm baking? Why is the skeleton not where I expect it to be when I'm baking? 90% of the time, it's because there is a tick delay issue, and you need to try to figure out where it's coming from. So I've shown you a quick example in 5.8. We didn't make it for 5.7. We have an option to only run the graph once, so you have a much faster way of catching those tick delay issue if you have any. But in general, I would just say, think about your logic. What needs to be executed first before you get to the next part? Are you sure that all your nulls or your transform have been computed properly before you move to the next part? The execution order is very important. It is not a dependency graph. All right, 5-minute break. Thank you. I'll see you right after to talk about backward solve. Cool. That's my cue. All right, we're back. Last part. I know it's a lot of information. Hopefully, you get an idea of what is needed and the things you need to be aware of. You get familiar with a bunch of nodes that are very useful. Yeah, I know it's a lot. It will take a moment for anyone to process this information. But we're going to talk about backward solve now and how important it is in the engine, and in my opinion. So the backward solve is just simply a way to match your rig onto an existing animation. You might be like, hey, I don't need to do that. I just have my rig and my animators are using my rig, and they're fine. But there's a lot of cases, I would argue, that where you get some motion capture maybe, or maybe you get some animation online from Fab or from anywhere else. You may have animation that your animator worked with in another DCC, or maybe you already are in engine, but you're doing an update to your rig that is not quite backward compatible, and so you kind of need to find a way to reapply your existing animations to a new version of the rig. So there's a lot of use case for the backward solve, and I would highly recommend always adding one when you are building your rig. You can see it this way: the forward solve is here to compute the position of the skeleton using the controls. And the backward solve is the opposite. It's here to compute the position of the controls using the skeleton. All right, so let's move to the graph again. I'm going to switch my screen. And we can take a look at our creature. And we're going to go in the backward solve. Let me close a bunch of tabs. I have a lot of tabs open. This time, I'm not going to build the graph from scratch. I'm going to spare you the time of watching me creating the same nodes over again and over and over and connecting them, because the graph is actually fairly simple. And I think it's going to be better if we just go over the graph together. I explain to you what each node is doing, and you will see that there is really not that much in there. So it's fairly simple to recreate, and that's also why I highly encourage you to create it. First, because this was not built yet, I didn't connect the backward spine, so I'm just going to do that quickly. I'm going to get my spine bones and connect that into here, and my spine controls, and connect that in here, and I can connect all that together now. Excellent. So this is the backward solve. And the backward solve is just another event that is running anytime we want to have a backward solve, a solve of the controls onto the skeleton. And you will see, I'll show you a couple of examples where it's being used. Quick notes, backward solve is just, again, another event. We like to put each event in its own graph, so you can create a new graph by just clicking the plus button over here, and that's giving you a brand new graph, and you can create your event here. Also, another side note, you can create custom events. So I think it's called user-defined events. And you can rename that my event, Jeremy. I don't know how to spell my name. And you can call that event so anytime you want. Why are those events useful? When you start building tools, it's also maybe sometimes very useful to be able to trigger something from the control rig. The way we use it, we wrote a tool to bake IK to FK on the whole timeline, not just on the current frame. And this whole baking just needs some matching between controls and all that stuff. And so it's very convenient to do it in control rig. So we created a custom event, and we can call this custom event from outside of control rig, from a tool. So just a very quick side note on the events. You have the standard events that you have seen, the construction events, the forward events, and the backward events, plus the post forward and the pre-forward and post-forward. But you can also create your own custom events as well. All right, go back to the backward solve, and let's take a look at this graph. First of all, very nicely organized by Ferris. The white part is my addition. Again, very easy to read. I love that. I know exactly what's going on. On top of that, it's mimicking the layout of the other one. So I am fairly sure this is the body and the roots. This is the arms over here, and we have the legs. Great. I'm going to feel very comfortable navigating through this graph. So let's take a look at what's inside. The very first thing he's doing is he's solving the root bone and the root control and the body control, and he's using this backward FK function. So we're going to dive right into it and look at what it does. It gets a list of bones, and if you remember from what Ferris did, every time he's building an FK control, he stores it as a metadata of the bone. So just by looping over the bones, he has access to the control. And then from here, is either using directly the transform of the bone, and is matching the control to that, or is using a project new parent in case there was an initial offset. So if you don't have an initial offset, you can just match the bone directly. But if there was an initial offset, you may want to use a project new parent. We're almost at the point where I'm going to explain what the project new parent does. So that's why he has it here, and I think the body especially had an initial offset. So we definitely want it to be checked here. But I think for the fingers, for example, is reusing it, and you see it's not using the maintain offset because there was no initial offset. To be fair, it wouldn't make any difference if I check the initial offset and the offset is 0. I could have that checkbox. It would work exactly the same way. Which leads me to my backward spine. In here, I'm not checking for the initial offset. I've been lazier. I just do the projection to parent. I don't think there's, when the way I built it, there's no initial offset. So the offset is 0, but it's fine. It still works because the initial offset is 0. So what I'm doing in my spine, I'm actually making an array of 0 and -1 because I want to iterate over the first control and the last control. And you remember the last control can be also accessed by entering a -1 into the array. And that's really just the two items I care about. I care about the first control and the last control, and I care about the first bone and the last control, the last bone. And from there, all I do is I set the transform of the control. As you can see here, I set the control of the transform to match the first bone or the last bone. So I'm using the projection new parent. Okay, let's go over the projection new parent. I've talked enough about it and why it's in 95% of the case the nodes you want to do when you want to do when you're tempted to do a parent constraint or you want an object to follow another one. What is a projection new parent? You have to put the child and the old parent and the new parent. But if I come from here and let's do a couple of get transform here, and this one is going to be the child, and we're going to grab the initial transform. So the transform at rest. And then for the parent, we're going to grab the initial transform as well. And then we're going to grab the current transform. So what we do is when those two objects are at rest, their initial transformation, we're just going to compute the delta between them. So here I can do make relative and pass the child and the parent. And this returns the transform, which is the delta between the initial position of the child and the parent. And then simply using the parent current transform, we can turn that into a make absolute and basically just reapply this delta on the parent current position. So this is how we're maintaining this offset. We are computing what was the original offset at initial position, and we're reapplying this initial offset to the current parent's position. That's it. This is what the projection new parent is doing. And is, in my opinion, 95% of what you want to do with a parent constraint. You only want to do that. The parent constraint, if we create one, parent constraint. First of all, constraint is not a good word because constraints kind of imply that there is this dependency connection. It's not. There's not. Parent constraint is only computed at that time in the graph. If you move something later, it's not going to offset it again. It's only offsetting when you tell it to offset it. So bad choice of word from us. Constraint is not really a word that I agree, but this is how we decided to name it. We were trying to make it easy for people coming from other DCC to find their way around. So that's why we name it this way. But also a parent constraint can take more than one parent, and those parents can be weighted. So I'm sure you can imagine that having multiple parents and weights on those parents must be more computation. There's more things to calculate. So this is why the parent constraint is just a slower node to use, because when you want to just attach one object to another one, you're giving a node that can do much more than that. That can filter things, that can have multiple weights and all that advanced settings things that really you don't care about. So it's not that the parent constraint node is not going to give you the result you want. It's just that it's a node that can do so much more that you are using a node that is going to be slower than just simply using the projection new parent. So highly encourage you, 95, 99% of the cases, to use a projection new parent rather than a parent constraint. And otherwise, it works the same way. This little combo is what you want to do. Now, one more thing I wanted to point out, make relative, make absolute, what are those nodes? If you know a little bit about the math behind parenting, you know that it's just multiplication of transform or multiplication of matrices. So make absolute is exactly the same as a multiply transform. This is exactly the equivalent. Same thing. And make relative is the one where you invert one of the matrices first to get the delta between two transform rather than directly multiplying them by one another. The reason I love those make relative, make absolutes so much, it's because I personally, after 20 years of doing that, still can't remember in which order the multiplication is supposed to happen. Multiplication of transform, a times b is not the same as b times a. I forgot how we call that. Is commutative. I forgot. It's like seventh grade math and great. Anyways, it's not the same. A times b is not the same as b times a for matrices. And when it comes to make relative, you have to inverse one of them. And I can never remember which one. So for me, in the past, it's always been a game of trying one multiplication and realizing it's the wrong way, and then I inverted the wrong one. So it always takes me 4 attempts to do the math correctly. So these nodes are just simple matrices multiplication. This one has an inversion inside of it, but otherwise it's just that. And the fact that they have clear names and clear input names make it so much easier for me to use them immediately. So, but otherwise, those are just transform multiplication, and the whole thing is exactly the same as a project new parent. Hopefully that clarifies a little bit why we keep telling you project new parents, or maybe I'm the first one. I don't know if Ferris banged on it yesterday, but you will keep hearing me saying that you don't need a parent constraint. All you want to do is project a new parent. All right, hope that made sense. We're going to move forward. Here we have the backward FK for the clavicle, so same exact node as the one we used before, so I'm not going to go over that. There we have the backward limb, so for the arms and legs. So if we jump into it, well, look at that. We have a backward FK solved again, because the FK controls are just other FK controls. So the way we backward solve them is the same way we backward solve any other FK node. So this is the same function that we were using before for the clavicle or for the root bone, that we are this time using for the FK control of the limb. And for the backward IK, well, yesterday Ferris showed you how to do a match IKFK. And I'm sure you can understand that match IKFK is pretty much the same as a backward solve, because what you want to do is you want your controls to match a given position of the skeleton. So we are just reusing straight the backward IK function that Ferris yesterday created. And again, you can see now, why did it call them backward FK and backward IK? Well, it's because we're actually using them in the backward solve. And for us, it's the same thing. So if you look into that, it's a little bit more fancy. He's got this project new parent, and then he's got the compute ball vector. I believe he went over that, so I'm not going to cover it again. Look at that. It's a fancy graph, lots of nodes. Great stuff, but it's exactly the same logic that you are using when you do a match IKFK. So very reusable. Over here is getting all the base bones of the fingers. So I'm imagining this is the list of bones like the first of each finger, so index 1, middle 1, and all. Then for each of these bones, he's getting children. Type of search, he could have used bones. That would be a little bit safer, though there's nothing else in there. And for each of these list of bones that he's created, so for each finger chain, he's doing a backward FK again. Excellent. So very easy. Then he's doing that for the right arm, and because he's a little lazy, he's taking the same bone list, and he's just doing a search and replace of the left side to the right side. He's not lazy. He's smart. And then he gets the opposite chain. He's getting all the right arm bones, and he's doing the same backward limb. And for the fingers, he's doing the same thing again, where he's just getting the fingers on the other side by just doing a simple search and replace. and doing a backward FK on those as well. And then there's the leg. The leg, he's got the leg bones over here. Directly inside the limb because we use the same function for the arms and the legs. And the same thing again for the right side where he's getting the mirror joints and backward solid. So you see this graph is very simple. There's actually just three functions. There is the backward FK, the backward IK, which is inside the lib, and then there is my backward spine because I'm fancy and I have a slightly different logic. Honestly, if I had stored the control the right way, I could probably have used the backward FK, but I took a different path anyways. It's not a big deal. So the only thing that is missing here is the reverse foot. So we're going to build this part together. It's a little annoying as well. The reverse foots are a little special, so you will see that we have to do a bit more. That's why I kept this one to build together. But before we do that, I want to show you how do we debug a backward solve. So if you go inside the preview settings, you have the preview controller. And in here, you can use a specific animation. And we're going to use our robot test. And you can see immediately that some animation is now playing on my robot. But, just the head and maybe the hips, I'm not quite sure what's going on here. Well, it's because we are still in the forward solve. And all the bones that I'm controlling with my rig are being overwritten by my rig. That's the point of the forward solve. So it's only the bones that I have not set that are driven by the animation. So not really useful. It's not what I want. I'm going to go here, and we're going to switch to the backward solve. And this animation is over there. And we're going to pause that. Let's just go back and stop the animation. And now you can see that my controls are matching on my rig. Okay, so that's coming from the backward solve. I can show you that if I disconnect the backward solve and I'm going to scrub, you can see that the controls no longer follow. And if I just compile and move back to the backward solve, the controls are back at origin. You can see some controls are actually here on the clavicles and all. It's just because they are parented under the I key in the skeleton, so they are just following the skeleton, but they are actually not matching properly my skeleton motion. So if I plug back the backward solve, you can see that everything is matching the rig. Cool. We done? No, we're not quite done. We are looking at the backward solve. We're looking at the control, how they are matched on the skeleton, but we're not really looking at the final result here. The skeleton is not being affected by my rig. For that, we need to run the backward solve and the forward solve in a sequence, one after the other. So you can do that with this fourth solve, the backward and forwards. And if I do that now I'm looking at the final result. I'm looking at what it's going to look like when I bake my rig onto the existing animation. And it looks pretty good, but I'm going to click on this to toggle between backward solve and backward plus forward. And you're going to notice a few things. Oh, there's a couple of things that looks different. Let's try to zoom in on it. Well, I noticed two things. My spine here is not exactly in the same position. And here on the leg, there's a little twist as well. When I show backward solve, I'm showing the raw input of the animation. And then when I'm showing the sorry about that again. I promise it must be one of the last time. We're almost done. When I show the backward solve, I'm showing the raw input of animation. And when I show backward plus forward, I show how it looks like once my rig has been baked and is driving the animation. And there is a difference. Why is that? Well, it's not really because I did a bad job. It's because it's possible that you get a pose from the skeleton that your rig cannot simply match. You maybe get some motion capture or some animation done with a different rig that your rig has not been designed to match. And in my case here, why do we have a difference on the twist of that joint? It's because my rig assumed that the plane of the IK cannot be broken. And this rig apparently, this animation apparently does break the rig where they added some twist on the first bone. I could easily add a control to my rig to add an extra twist offset to the bone, and then use that to my in my backward solve to make sure that the control is matching. No issue with that. But my current rig isn't supporting that, and that's why I have a difference. And there it is a question of, is it acceptable? Is it what you expect? Or are you missing controls and do you want to add more to your rig to support that? In this case, I would argue, and you feel free to think otherwise, but I would argue that this twist is not supposed to be there. And something in the mocap or the animation process introduced a twist that we don't really want, because if we look at this joint, it's creating a little intersection. I mean, it's not too bad, but if we can imagine that if it was bigger, it would look like a broken character. So I would argue that I don't want to fix that, because I think my solve is actually making the animation better. It's fixing this issue. Spine is the same. I told you maybe I wouldn't rig this character with a spline, because it might be a little overkill for just three bones really next to each other. And I'm guessing that this animation was not done with a spline. It was probably just FK controls. And there's some FK poses that I cannot match with a spline. If we rotate the joints very hard, I only have 4 points in my spline, so I'm not going to be able to get a perfect match. So that's also why there is a little bit difference in the spine. Again, does it matter? It's up to you. It's up to what you want to get from your animation. Do you expect a perfect match? Well, then you need to rework your rig to make sure that it can handle those poses. If you think that this is just bad data that came from the random animation you found online, or from the motion capture session that you get, then maybe that's totally acceptable and that's actually desired. It's a way to clean your rig and clean your animation and make sure that every bone is behaving correctly. So backward solve and move to the backward and forward, we can see that those bones are not matching what I expect. So this is the part I have left to do, and this is the part we're going to build together. All right, so let's get to it. We're going to need our left foot bones, and we're actually going to need as well our IK left leg control. The thing here is we said that this offset needs to come from the effector being offsetted, not from the ankle being in that position. The IK control should really stay locked to where the heel is. So that's the first thing we're going to do. We're going to do a project to new parent. That's your new favorite node. And we're going to project this control onto the heel bone. The heel bone being the last bone of the hierarchy of my foot. So I'm going to use that here, and then we're going to do a set transform. Plug that here, and we can plug that over here. Okay, so now my control is over here, and I may just things are worse now because I have this big offset, but it's because now I want to introduce back the ankle offset using the reverse foot and not the IK control. Excellent. Going to turn that into a function. Last time I promised you see me collapsing something to function and creating a sequence node. Good habit. If we work together one day, I will definitely ask you to do that the same in your graph. And you can come up with your own rules, but I highly recommend that you think about how reusable all of that is. Okay, cool. So the child, let's go here. The child is my IK control. And the array is my bones. And I actually don't need that extra pin, but I need to get IK control here. and plug that here as well. And then here we're going to do the shortcut for the bones. Beautiful. Again, very clean graph, very happy with it. Excellent. Okay, so next thing I need to do is I'm just going to match the controls onto the bones. Always a good habit. Making sure everything is where it should be. So I'm going to get my bones again, and for each of them. So I'm going to match the bones this time. So I want to make sure that I do that in the order, in the hierarchy order of the. Sorry, I'm going to match the controls. So I want to make sure that we do that in the hierarchy order of the controls. And we know the controls are reverted compared to the bones. So once again here, I need to do a reverse. And because I need to do a reverse, I need to do a clone. So I'm reverting this chain. And this is what I'm going to be using to loop over my bones. I'm going to look at the bones, but I'm going to look at them in the reverse order. And for each of these bones, I'm going to get the control that's match this bone. So control, and it's a ring element. And I guess we can just simply match everything. So here we're going to do a set transform. We're matching the controls, and we're going to match that onto the position of the control, the bone. Right here, right there, and right there. Cool. Didn't make much difference, but it's needed. So we're going to get this. This is correct. And now, so the ankle is over here. Let's go back to backward solve only. The ankle is over here. And we want this offset to happen with this control, this last control. So what I'm going to do is I'm going to simply project the ball joint, the ball control to the position of the ankle. And that's going to make it work perfectly. So I can grab my bone. This time it's the first bone that I care about. And I'm going to get the metadata again. Let me just grab that node. Saving myself a couple of clicks. And I'm going to do a project to new parent. So I'm going to project to new parents onto the position of that bone, the ankle bone. How do I access the ankle bone? Well, the ankle bone happens to be the parent of my ball joint. So here I can just do get parent. And that's going to be my, my parent here. Excellent. Just do a set transform on this control. Plug that here and plug that to my sequence. And now, if I switch to backward and forward, you can see I have a pretty good match. So that worked. Excellent. Let's go back to our backward solve. Let's take this and do it for the other foot very quickly. We can get the bones of the right foot. And the IK control, we're going to need to get right IK leg control. Plug that here. And everything should work. Oh, I didn't rename this function. So that's going to be backward foot, compile, and save. And that should work. Excellent. So let's take a look at where is the backward solve actually used, because this is the way you built it and debug it and make sure everything is working, but you're not really using it from this interface. You are using it when you are in sequencer. So I'm going to grab the scale mesh. I'm bringing it inside that level. I'm going to create a new sequence. Right there is totally fine. Bringing the SKM to sequencer, and we're going to load some animation. We're going to load the test animation that I have, and you can see that it's the same animation. Oh, did we fix this issue? I want to use this opportunity to show you a common issue. You're like, oh, my character is disappearing. What's going on? It's because by default in the engine, in order to define if an object is in the camera view or not, it's looking at the root position. Maybe a bit bigger than the root position. But so if this root is going off screen, your character might disappear. How do you fix that? There is a very simple way. You can use a physics asset. Easiest way would be to right-click on it and do create physics asset, create an assign. It will create and assign the physics asset directly. Let's do that. It's going to create another one. We have one here. Um, and usually it's all you need. It creates some very quick capsules. Physics assets, this is used for physics. I'm not going to cover that. I believe Chase might cover a little bit. I mean, Chase is going to cover the physics in Control Rig. Before Control Rig, everything was done inside the physics editor, this editor. I think he's going to maybe show you that you can use a physics asset inside Control Rig. I forgot if he's doing that. But anyways, a physics asset is just a bunch of capsules attached to your bones. They can be used for simulation, and in this case, the engine also using them to define the bounding box if your character is not staying next to the groups. And so you can see now that regardless of where I move my camera, my character is not disappearing because now it's using the physics body attached to it. Just thought I could use this opportunity because otherwise my character is going to disappear. Look, so that's the same animation we had before. And now I can do and right click on the track and do bake to Control Rig. I'm going to use the rig I just created, which is day 3 start. I've been working on that with you guys. So we're going to do this. There's a couple of options. You can look into that. And boom, it created my Control Rig track with all the keys on all the controls. And you can see that my animation is moving. This animation here has been deactivated, so I'm not playing the animation currently, I'm playing the controller. But let's take a look. Let's reactivate the animation. First of all, you can see that the head is moving now. It wasn't moving because we haven't done anything in our rig to take care of the head. You could use the spine functions I created, by the way. I think this is what Matt is doing tomorrow. But so the head is moving again now. Anyways, and the rig is overwriting everything else. If I mute the rig, you can see we have the same exact issue on the leg that we saw when we were debugging the rig. Okay, so it shows you that it's exactly the same result and probably what you want to do. Cool. So this is how you bake to Control Rig. Your animators has now the pleasure to deal with 2 billion keys. They love that, I'm sure. We have some algorithm to reduce the keys, but you know that it might not be ideal all the time. So I want to show you another way you could do it. I'm going to delete that track. And this time, I'm just going to do plus Control Rig, and I'm going to use the layered Control Rig track. So I'm going to check this option, and it disappeared for some reason. I'm going to check this option, and I'm going to look for the same rig I just built. So day 3 starts, the one we just built together. And now it's added as a layered control rig. And if you can see, look at that. My controls are moving as well, but there are no keys here. And this body control is always at 0, but still moving. And if I move it, hey, it's moving my character around. So this is a very convenient way of adjusting animation, where you don't need to create all the keys. You assume that your base animation is mostly correct, and you're just going to do a few edits on it. And so, for example, let me reset that key. If I go to I notice here, he's moving the leg, but the weight is not really on that leg. I don't think this is really a great animation. So I'm going to go from here. Sorry, I don't know who animated this, so sorry for criticizing animation I'm just using for the first time. So I'm going to go here, and when the leg is up, I'm going to shift the body weight on that leg and raise it a little bit, maybe move it forward a little bit. And then when he dropped the leg, maybe I should do that a bit more earlier. You're going to see my amazing animation skills. Drop the leg here. We can go back to the pose we had before. So now I did a small adjustment to my animation, and I only have 3 keys to worry about. So much easier. Layered control rigs are pretty powerful because you can layer rigs on top of another rig. So you can imagine a scenario where, hey, you remember that twist issue we had here? I could layer a rig on top of this rig just to add this type of small details. So you could imagine that, hey, 90% of my shots just need a very simple rig, like this rig, this biped rig. But there is this one shot where, for some reason, I need to disconnect the leg, like it's being hit, and I want to disconnect the leg. My rig doesn't support that by default. You could create a rig, a layered control rig, that gives you control to those bones and offset them by layering the rig on top of the existing rig. So try to think about the possibilities you may have with layered control rig, where as soon as you have a backward solve, you can start stacking rigs on top of each other. Not always what you want to do. It depends of your scenario, the way your character is built, but definitely a very flexible way to look at your animation. And that's it for me. That's all I had to say today. Let's just go back quickly to my slide. Over here. So we went over the backward solve. All the details of the step-by-steps are inside the slides if you want to take another look. And that's all I had, guys. Thank you.